Hey guys, so today we're going to talk about the unit circle a little bit in detail. So I'm going to use triangles to prove the x and y values of the unit circle. So let's start by making our triangles. I'm going to use the Pythagorean theorem. I don't know if I already said that. So if I make a line going this way and a line going this way and a line going this way, and a line going this way, you can see that these two triangles are the same triangle, and I also know that the angles correspond. So this angle right here is 60, and this angle right here is 30. This angle here is 30. And this angle here is 60. So I know that these two angles are the same triangle. These two triangles are the same triangle, just flipped. There's also one more piece of information I know from the unit circle, and I don't know if you've seen my first video, but in my first video I explained the unit circle and how to remember these values a little bit easier. And what I said in my video is that to remember that 30 degrees is halfway up the y-axis, so that means your y value for 30 degrees is 1/2, and 60 degrees is halfway down the x-axis, so your x value is 1/2 at 60 degrees. So your 1/2 is your y is 1/2 at 30, and your x is 1/2 at 60. So that means that right here, this purple line here is 1/2, and this purple line here is 1/2. So I have enough information on this triangle to solve some stuff. So the unit circle is a radius of 1. So that means our hypotenuse for all the triangles that we fit in the unit circle will always be 1. So our hypotenuse is always going to be 1. So let's start with redrawing our triangle so we can have a better picture. So I'm going to redraw our triangle. Oof, that's a little wide. Let's go a little bit lower. Oh, that's good enough. Alright, that's 30 and that's 60. And this here is 90. Our hypotenuse, our C, is 1. And our short side is 1/2. But we don't know our long side, so we're going to label it B. And this is going to be A. So let's solve for this triangle. So let's find B. So the Pythagorean theorem is C squared equals A squared plus B squared. And we have A and we have C, so let's isolate B. So we can rewrite this as C squared minus A squared equals B squared. So now let's plug in our values. So 1 squared minus 1/2 squared equals B squared. So that's 1 minus 1/4. And I can rewrite this as 4/4. So that means 4 minus 1, and that gives me 3/4 equals B squared. And I take the square root of both sides, and that gives me the square root of 3 over 2 equals B. And that's my B value. Now let's take sine of 30 degrees. That's opposite over hypotenuse, so that's 1/2 over 1, and that's just 1/2. Cosine of 30 degrees is going to be adjacent over hypotenuse, so that's going to be square root of 3 over 2 divided by 1, which can be rewritten as the numerator as itself. And cosine of 30 and sine of 60 are going to be the same value, because the opposite of 60 degrees is the adjacent of 30 degrees. So that gives me opposite from 60 degrees is the square root of 3 over 2, and our hypotenuse is 1, so we can just leave it like that, and that's the same value as cosine of 30. That means that cosine of 60 is equal to cosine of 60 is equal to sine of 30. So that's adjacent to 60 degrees and the hypotenuse. So adjacent to 60 degrees is 1/2 and the hypotenuse is 1. Now, what about 45 degrees? What does my triangle at 45 degrees look like? So at 45 degrees, my two sides are equal to each other. So angle A and angle B are equal to each other, and C is equal to 1. So I could rewrite the Pythagorean theorem for the angle of 45, the triangle for the angle of 45. I can rewrite the equation as c squared equals a squared plus a squared, because b is equal to a. And that gives me c squared equals 2a squared. C squared is 1 squared, because since we only have to solve for a, we can just get to work, because a and b are the same value. So we don't have a third variable to look for, so we just get to work. So 1 squared is 1, and we need to get this a squared by itself, so we need to get rid of this 2. So we gotta divide it away. So that gives us 1/2 equals a squared. And then take the square root of both sides, and that gives me 1 over the square root of 2 equals a, and this is not a rational answer, so I have to rationalize it by multiplying it by square root of 2 over square root of 2 to make the bottom not a radical. So that gives me a equals the square root of 2 over 2. And that's how you get these values. So I can use triangles to explain what happens at 90 degrees also, but it kind of makes a nonsense triangle. But I can also use limits, or the idea of limits, to explain what I'm doing. So a limit is basically saying, let's say at the value, like if I have a number line at the value of 1, my function doesn't exist because of a 0 in the denominator or something like that. The function looks like this, and there's a hole right here. So like imagine that. I can look right here at this point and right here at this point to figure out what's going on, or what was supposed to go on over here. So I can look here at 0.9999, or here at 1.0000001. 001. I can look at these 2 points and be like, it's going this way over here, and it's going this way over here. But if I look this way, it's supposed to be over here somewhere. But something happened, and it kind of fritzed out, and we have a hole there. So we can use math to be like, what's happening here and what's happening here, and kind of use our logic to figure out what's happening here. So if I were to have a triangle for 0 degrees, I'd have a triangle that looks like this. So let's say my angle, my theta degrees, is super close to 0. My hypotenuse is 1. That means that the closer this degree gets to 0, the closer this side will get to 0. And the closer this side gets to 0, the closer this side gets to the length of the hypotenuse. So this gets closer to 1. So the closer the angle gets to 0, the closer this side gets to 0, the closer this side gets to 1. And the same thing happens at 90 degrees, but on the opposite axis. Because this way, this right here is the x-axis, and this right here is the y-axis. So let's say this point right here, this point here makes an angle of 0.0000001, like 0.00001 degrees. It's super small, but just get the idea that it's so small that you might as well just call it 0. So at 90 degrees, the same idea applies, but this is more of a reference angle, because here we look at our angle from the x-axis. So if we come this way, our angle right here is the actual angle. But if I try and figure out the angle in the gap here, I can also get the same value. Because this triangle plus this triangle makes 90 degrees. So they're going to be, I believe the term is supplemental, but I can't remember right now, I'm sorry. But these two triangles are the same triangle, so if I solve for one triangle, I can solve for the other triangle. So let's do, what color? Let's do blue. So this would be 90 degrees, and this here is 0 degrees, as close to 0. So I'm going to call this point 89.00. Not 0099, my bad. 89.99 degrees, and this point here 0.00001 degrees. Let's just say that those are the values. If I do sine of 0.001, one more 0, we get 0 over 1, so that gives us 0. That's this value right here. And if we take cosine of 0 degrees, or 0.001, you get 1 over 1, which is 1, which is this value right here. And over here at 90 degrees, this will be 1, this will be 1, and this will be 0. We're going to look at this angle again. No. We're going to look at this angle. I'm sorry. Haha, sorry. This angle. So, opposite of this angle. So, a sine of 89.99 degrees is going to be 1 over 1, which is 1. And that's this value right here. And cosine of 89.99 degrees, cosine that's adjacent over hypotenuse, and that's 0 over 1, which is 0, and that's this value right here. So why is it important to know why these values are there? Because we need these values to be able to graph y equals sine x or sine theta, and y equals cosine x and cosine theta. Oops, I wrote x again. But you're like, wait, what do you mean graph sine over x or sine over sine of x or sine of cosine? Well, our x values for these points is cosine theta, and our y values here is sine theta. So the points of the unit circle is cosine theta, comma sine theta. So our x and our y, our x is cosine theta and our y is sine theta. So the graph of sine x, so this is 2 pi, because we're going through the circle, so I'm going to label this the rest of the way real quick. So this is 0, -1. This is -1, 0. So the unit circle, I'm going to use the unit circle to graph sine and cosine real quick. So I'm going to use the unit circle. So here at 0 degrees, sine is at 0. So that's my first point. At 90 degrees, sine is at 1. At pi, sine is at 0. At 270 or 3/2 pi, sine is at -1. And at 2 pi, sine is back at 0. So sine looks like I'm sorry, I have to sketch it very badly because I'm not used to using this tablet yet. So sine looks like an N. So that means that when you go around the unit circle to 2 pi, because one time around the circle is 2 pi. So when you go one time around the circle, you make this shape using the sine values. And cosine, when I go around the unit circle from cosine, ooh, I need to fix that. Right there. There we go. At 0 degrees, cosine is 1. At 90 degrees, cosine is 0. At pi, cosine is -1. At 270 degrees, or 3/2 pi, cosine is 0 again. And at 2 pi, we're back at 1. So cosine looks, like, ooh, that's really bad. Anyway, looks like a U. Cosine looks like a U. So that's why it's important to know these values, because you're going to need to know them to be able to graph these two. And we're going to talk about them a little bit more in detail in the next video. So I hope this was helpful, and I hope that you learned something, or it helped in any way. I just hope it helped. Alright, see you in the next video.